Sorry about that. So good morning, good afternoon, good evening, wherever you are across the world. Dear authors and invited guests, it is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom. On behalf of ICICT 2021 and the Global Research Foundation. As every one of us is passing through unforeseen circumstances due to COVID-19, we wish everybody and their families a safe time, and together, hopefully, we'll get past this very soon. Further, with immense happiness, I would like to share that we have received an overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference. And the papers will be published in 4 volumes this year. We're grateful to all the guest presenters today on this platform who join us digitally for this conference in these unprecedented times. And hopefully this will still lead to a fruitful outcome in terms of technical knowledge. We hope that you enjoy the next 2 days to come and the interactive sessions to join. I'd like to welcome you to technical session 3F and further introduce you to the chair. However, unfortunately, because of me being slightly late, he has introduced himself, and very kindly, thank you very much for introducing and explaining the guidelines of 12 minutes to speak. So I'd like to take this opportunity just quickly to extend my gratitude to our chair today, Sin-Suk Cho from Great British University, who is a senior lecturer and a course leader for 2 courses, actually, computer networks and a master's, which is computer network administration and management, also in the School of Computing at the University of Portsmouth. So he's very interested in software engineering, and I'm sure he'll thoroughly enjoy the talks we're about to come. So without further delay, we will move on to our first speaker, who is Ursula Jagodzinsk-Samajskan from Poland. Again, I do apologize if I am mispronouncing any names. I wholeheartedly do apologize, but over to you, ma'am, if you'd like to take over the screen and start your presentation. Thank you.
Thank you. Good afternoon. My name is Ursula Jagodzinska-Szymańska. I work. Do you see my presentation?
No, not yet, ma'am.
Sorry.
Sure.
Yep, that's perfect.
Yes, all good. Thank you, Jay.
Good afternoon once more. My name is Ursula Jagodzinska-Szymańska. I work for PITRADWA, which is an institute in Warsaw. I produced the presentation algorithm classifying brain signals in the control problem. I prepared this presentation together and under supervision of Professor Sendek, who also works for PITRADWA and the University of Science and Technology in Bydgoszcz, which is also in Poland. Let's see what was done, the method, and the purpose of work. So the classifier was the classifier of brain signals was developed based on even related desynchronization and even related synchronization phenomenon. The tools of the method are following: the inverse problem, which was solved with the use of Moore-Penrose matrix and least squares method. The statistics was calculated. There was found the minimum spanning tree with the use of graph theory, Gauer's algorithm. And as I said, even related desynchronization and even related synchronization were used. To read signals from the brain was used the Epoch headset of the Motive company, which is wireless. And we constructed the whole system working as a brain-computer interface. The classifying algorithm was implemented in MATLAB environment. And the purpose was to use the classification result as control impulses. Here we see the simple device designed for the purpose of the work, controlled wirelessly via Bluetooth or Wi-Fi, with the use of classification results as control impulses. The green lead goes on when imagining right hand movement, and the red lead goes on when imagining left hand movement. And the classification results are observed as well in the dialog window on the screen of the computer, as you can see here. And here we see the whole system working as brain-computer interface. We have a computer with classifying program. The dialog window is visible on the screen, and the device and a computer with classifying program transmits control impulses to this device via Bluetooth or Wi-Fi. The concept of the system you can see on the screen, and the classification algorithm works on the basis of reconstructed signal sources. And what is original in the approach is that the feature selection is done based on graph theory, Gauer's algorithm. It is possible to generate reports from measurements and control sessions. And thanks to our algorithm, we received a high compatibility of imaging hand movement with the classification result. Measurement parameters adjusted to individual characteristics improve classification results. And let's see the dialog window, which opens after the classifying program is turned on. You can choose features. The dialog window enables setting personal characteristics. These are time intervals, because even related desynchronization depends on the person. It is personal, and the frequencies of analyzed signals can be set. This also is personal, where in exact moment is best seen even related desynchronization. And another parameter which can be set is the head radius. And in the dialog window, it's possible also to set other parameters like communication and hand selection. And the classification results, which are transmitted via Bluetooth or Wi-Fi to the device, are always visible in the classifying window. We see it here. And the dialog window makes it possible to observe results of classification in a continuous way in real time. It allows us to change parameters during control process or measurement session. In the dialog window, we have also buttons, like you see on the screen. There is a report button which allows us to prepare the report from the control session or control or just a control. And main modules of the classifying program reflect the process of classification, and the most important is and the main function of control algorithm is data classification function. And this classification function allows to build a coordinate model for the head and electrodes. It lets lets us to solve the inverse problem, calculate t statistics, and to find the spanning tree with the use of graph theory, Gauer's algorithm, and to find the classification result. And the classification results are visualized on the device and in classifying window. So they to the device they are transmitted wirelessly as control impulses. As I said before, Gauer's algorithm is used to select features, and it finds the spanning tree, which includes all graphs vortices, and the graphs vortices are fields on cerebral cortex, while the edges are such that the sum of the weights is the greatest, edge weights are values of t statistics, and what's important that the sign of this sum is the classifier. Depending on the sign of the sum, the classifier will register the image of the movement as that of either the right or the left hand, and we can even say that the scalar is the classifier, and this is the result of formula for t statistics. The sample report in Microsoft Excel format is seen on the screen. We have the result of one measurement, which classification result is a right hand, and assumption was the right hand, so the result is correct. And we see the summary of 4 measurements, both for right and left hand, and all are correct. Thank you very much for your kind attention. If you are interested in the subject, please read our article. There are email addresses of me and Professor Sendek if required. If you have any questions, I will be happy to answer them.
Thank you very much. Dr. Chu, do you have any questions?
Oh, great. Thank you, Jay. I think I have quite a small, interesting question. Ursula, when you take samples, actually, do you consider different age group because the data collected from different age group might be different for your kind of training set and algorithms?
Oh, yes, this is true. To be honest, I performed some measurements, but I didn't choose. Yes, it is true. I choose a group of. I'm sorry. I choose group of persons. Lately, I tested 10 persons, and it was women and men, and in different ages. Some of them were young, and some of them were more than 60 years old, but I haven't seen a big difference between these people about 30 years old and these who are about 60 or more. Yes, but I analyzed with a few persons such tests and such measurements. Thank you
great.
for the question. It's a very good question, and it's good to analyze, make such analysis. Thank you very much.
Yeah, great work, great work. Thank you very much.
Thank you.
Thank you very much, Ursula. We'll move on to the next speaker, who is Usha Mehta from India, whose paper's title is Transition Probability-Based Detection of Hardware Trojan in Digital Circuits. Ms. Mehta, if you're here, if you could unmute yourself, just say hello to everyone, and then we can move with starting your presentation.
Good afternoon all. I'm Usha Mehta. from Ahmedabad, India. Today with me, my co-author is I am having fever and I'm little feverish. So anyone I have throat pain. So I request my co-author to continue with. So over to you, Jess. He is here with me. I have called him.
Perfect. Thank you very much. We hope you feel better soon. Jess, if you like to, if you have a presentation, feel free to share it and then continue. And we hope you feel better very soon.
Hello, good evening all. Are you able to see my screen?
Yes, we can see and hear you.
Okay, thanks a lot. Thanks a lot. Thank you, ma'am. Thank you for giving me this opportunity. Actually, Dr. Usha Mehta is my guide. I am Jayesh Popat. I am a research scholar at Nirma University, and my PhD guide is Dr. Usha Mehta. And our paper title is Transition Probability-Based Detection of Hardware Trojan in Digital Circuits. Let me go ahead with the presentation. My agenda of today's presentation is motivation of the research work. Literature review will cover a survey of different literature papers. Research work will include hardware Trojan detection proposed technique, its results and discussion. And at the end, I will conclude my presentation. Motivation, hardware security to ensure trust in an integrated circuit has emerged as an important research topic nowadays. So the figure shows the DARPA's model of hardware security and threats, which indicates the vulnerable steps of modern IC life cycles. Generally, modern IC design nowadays includes intellectual property core from third-party vendors, outsource the design and test services, electronics and design tools from third-party vendors. Moreover, the IC design houses have nowadays become fabless and they outsource the design to offshore fabrication facility for manufacturing. Now, such a business model to a large extent has relinquished the control that IC design houses had over design and manufacturing of the IC and making them vulnerable to various security threats. So let's take a look at the different security and trust threats. The first one is IC counterfeiting, which includes the overproduction, recycling, remarking, and cloning of the IC and tampering of the hardware devices. The hardware Trojans are generally defined as malicious modification made in an IC during design or fabrication steps, leading to malfunctioning of the IC, which is in field and causing serious consequences in critical applications. Leaking of sensitive secret information from crypto hardware through side channel and test or debug interfaces, and corrupting the memory to cause the denial of service problem. So our main focus is on hardware Trojan based attack. In terms of hardware trust assurance, we have investigated hardware Trojan attack and proposed its detection technique. The hardware Trojan are generally defined as malicious modification made during design or fabrication process in an IC by insertion of malicious circuitry. So the IC can therefore contain a secret or hidden function that can be activated under very rare input conditions. The Trojans are normally located at very low controllability and observability locations. So they are most of the time span they are inactive, and they can be triggered or activated under very rare condition at internal circuit node by an adversary. So such a modification to a functionality generally causes the disassembling of the entire chip or financial threat or security vulnerabilities. So there is utmost need of detecting the hardware Trojan or preventing the hardware Trojan based malicious circuitry. And the detection of hardware Trojan is possible through pre-silicon verification or physical verification or manufacturing test. Our proposed technique is transition probability based hardware Trojan detection in digital circuit. So the main objective is to detect the hardware Trojan based malicious circuitry inserted into netlist by an adversary. So we have considered actually ICICT 85 benchmark circuit, combinational benchmark circuit for our experimental purposes. The methodology would be like, initially we calculate the transition probability on each net on the netlist in the original design circuit netlist. And as I said earlier, the Trojans are generally located at low controllability and observability points. So to mimic this scenario, we generally insert the Trojan in the design at low transition probability area, and the transition probability on each and every net on the Trojan inserted netlist, which is useful to detect the extra malicious circuitry. Now I will explain the algorithm of our proposed technique. The first step is to set the logic 0 and logic 1 transition probability as 0.5 on primary input net of combinational circuit design netlist, and set the current netlist, which is under consideration as current design. Then we calculate the logic 0 and logic 1 probability on each net of the netlist according to the gate type traversing from primary input to the primary output. Then we compute the transition probability for every net, which is nothing but PTI, which is equal to PI of 0 into PI of 1, where I indicates the net number. PI of 0 would be like logic 0 transition probability, and PI of 1 is logic 1 probability for a particular net I. Once we have all the transition probability, we actually store them in a table in an ascending order and find out the lowest transition probability nets. And these are the nets which attacker can exploit and insert the extra hardware Trojan. So to mimic this scenario, we insert the extra hardware Trojan malicious gate in the lower transition probability area and evaluate the transition probability in the Trojan inserted netlist. At the end, comparing the transition probability of all the nets in the original and Trojan inserted netlist will lead us to the detection of the hardware Trojan affected area. So let me go with one of the example. Let's say we have considered ICICT 85C17 benchmark circuit, where we have calculated the logic 0 and logic 1 transition probability on each net of the netlist. And transition probability is defined as logic 0 probability into logic 1 probability. So net number, so the right side table shows the different net numbers and its corresponding transition probability in the original netlist. As it can be seen that net number 10, 11, 14, and 15 are having the lowest transition probability. And these are the location which attacker can target for insertion of the hardware Trojan, malicious circuitry. So to mimic this scenario, we have inserted hardware Trojan extra malicious gate at one of the potential location, that is net number 10 in the ICICT 85C17 benchmark circuit. And we calculated the transition probability on each net. So the right side table shows the net numbers, its transition probability in the original netlist and transition probability in the Trojan inserted netlist. And as it can be seen from the results, that net number 10 and 22 transition probability have been changed from its original transition probability value. So if we traverse back in the netlist from primary output to the primary input on chain transition probability path, we can easily detect the Trojan affected area in the netlist. So this technique is further implemented on different ICICT 85 benchmark circuit like C17, C499, C880, and C1355 with different types of Trojan gates. So from experimental result, it is evident that logic OR gate is most likely and suitable for the attacker, since it is making minimal effect on the modified transition probability compared to original transition probability on the primary output net. So in the conclusion, in this paper, we have introduced design for trust technique, which is transition probability based hardware Trojan detection in combinational digital circuit. And the technique is evaluated for different ICICT 85 benchmark circuit to successfully detect the hardware Trojan insertion in low probability circuit nodes. These are the references for today's presentation.
Thank you very much, guys. Dr. Chi, if you had any further questions, just like to thank you.
Very interesting work. Thank you, Jayesh. Now, it sounds to me it's quite a sort of interesting work. Now, have you identified some kind of a real scenario, for instance, likely looking at a typical computer system, will it happen in a CPU set, GPU set, or happen in a network interface or a storage set? So likely what part of the compute architecture it will likely to attract such kind of malicious circuits.
Basically, it will be not in a computer. We are not focusing on computer architecture, but we are focusing on the chips which is related to financial activities. So our basic purpose is like all the cryptography chips which are being used in credit card, debit cards, and all other financial activity kind of stuff. So there the password and all other details which are of prime focus that we want to make secure.
Okay. Yeah, that's fun. So it's the smarter chips you are talking about.
Yeah,
Correct.
correct.
What is the way you can actually, so we have seen a nice algorithm. So the next step will be what will be the actual tools, the ways. For instance, if I have a smart card reader, what will be the first step to prevent the chip from entering the the authentication process?
Yes. So right now we are sort of focused on combinational digital circuits. The chip which we are talking of, it includes the sequential digital circuits as well, because digital circuit ultimately it has the combination of both the circuits. So we have now focusing on sequential digital circuit, and then we will be focusing on the entire SoC design which is used inside the master chip and all those things.
Okay, great. Sounds interesting.
Basically,
And what kind of COVID action? So, for instance, a hidden activity where it's a kind of steal confidential data and direct the transaction traffic directions and that kind of thing. What will be the possible impact of the malicious chip?
so basically there will be a golden list, a probability list for each of the net. And then there will be a frequent testing algorithm which will be testing, calculating the probability of individual nets at a frequent time period. And whenever there is a mismatch, and we have identified some specific areas where there are the majority of the time the Trojan will be inserted that particular net. So there will be frequent testing, and whenever there is a Trojan there during the testing itself, the probability will change and it will identify that there is a Trojan inserted, and then the chip will itself become useless.
Okay, great. Thank you, Professor Yosa. Very interesting.
Thank you.
Thank you.
Thank you very much, Professor Mehta, and thank you, Mr. Bulbert, for helping out as well. We'll move on to our next speaker. Is Ali Aburas from the United States of America, whose paper title is An Improved Genetic Algorithm with Initial Population Strategy and Guided Mutation. So welcome, Ali, if you are here, if you could unmute yourself, and then we can proceed with getting your presentation started.
All right. Do you hear me, guys?
Yes, we can hear you perfectly.
All right. Okay. So next step, do you see my screen?
Yep, that's all.
All right. Okay. There we go. Good afternoon, everybody. My name is Ali Aburas, and I'm assistant professor at the computer CIT department at Morrisville, SUNY Morrisville in New York. I'm here today to talk about testing and the genetic algorithm and how it is being used in testing programs such as Java. And the improvements that I propose to increase its effectiveness and efficiency. So first of all, what's testing? So software testing is the executing of the program or application with intent of finding the software bugs. That's the goal of testing. And when we test a program, so another question comes to the testers, or sometimes the developers, when do we stop testing? So people define some criteria, and which is you need to hit or to get 100% of these one of these criteria, or sometimes it's compounds on these criteria. So such as statement coverage or branch coverage. That's what the criteria that I'm using in measuring the effectiveness of my tools, that I propose. As an example here, so we do have a Java program that implements stack. Okay, so as you can see here, there's a push method and a pop method, and then we have a peak that it shows the top of the stack. Here is the stack the size of the stack is 10. So as you can see here, it's in the array that declared here is 10. So that's the maximum of the stack. And there is 2 private methods. Are those methods that cannot be accessed directly due to the object-oriented properties. So how do we test? Basically, first one that's the people use is Think to set and create manually input. So you need to identify your test inputs. And as an example here, the structures and the public methods, we didn't include the private methods like the is full or is empty, and the numbers as an input here, and this is the range, the size of the numbers as an integer, so that's the range. So we need to select, that's our input, we need to select inputs executed towards the program under test, which is the stack, and then we see how much that we cover. As an example here, this is the inputs that we identify we call the 2-unit test based on our test input, and then we run these 2-unit tests against our code. And you see here the red, there is some tools that shows you the coverage, depends on the coverage. As I said, I'm using the branch coverage. So you could see here, you can see here, the red line means that we didn't cover this one. So you need to go back and think, create another inputs until that's your goal. It is not easy to get this 100%, depends on the properties of the program under test. But as you can see here, because to show that the stack is full, you need to create 10 pushes, right? Or 11 actually pushes, pack to pack. Because if you see pop between them, is gonna reduce the size. But as a developer, you need to think about this. Wait until you see here, you get the 100%. That's where you get the confidence that your program is works as expected. There is no crash. There is no kind of, you run all the statements and all the branches, which is the if statements here we are talking about when we talk about the branches, if then else. Okay. So it takes time. It's an expensive process to do the testing manually. So as a result, people thought about automatic this process. And the first way to do it is random testing. It's easy to implement. It's just randomly, very short to implement the code, but has some disadvantages. So people thought another way, there are different other ways beside the search-based software testing. So in search-based software testing, the problem of test data generation is converted to optimization or search problem. And then some some search algorithms, such as genetic algorithms, use it to automate the process of finding test data. So how the genetic algorithm works, as you can see here, is the GA usually starts with a set of possible test cases, test inputs. When I say test cases, it means inputs from the test input domain that we identify based on the program that you are testing. And then the GA performs genetic operators such as selection, crossover, and mutation to evolve its population. So it starts with the initial population and then start running, executing those inputs against the program and does some operator. But these operator, the GA genetic algorithm uses a fitness function to guide the search. So it's its goal to see which one inputs it's better that can hit close or to hit that, to cover that particular missing branch. Here it's in the selection operator is conducted in order to choose subset of the current population based on the fitness of the test cases. And then when I choose the best, there are different mechanisms to choose the best test cases, but when you choose the one, it goes to the cross operator where you combine the two test cases which have been previously selected by selection operator and produce a new test cases. And then it comes those test cases is muted, that it's randomly change something in those test selected and crossed over test cases. So this process can be iterated until either the optimal solution, you hit the 100%, your criteria, 100% as an example, branch coverage, or you stubborn conditions such as the time out holds. So as shown in the previous slides, the GA usually starts with a set of possible test cases that are randomly generated. Although the process of randomly selecting all test cases of the initial population from the search space of the problem is easy to implement, but sometimes it is, because of randomness, sometimes you miss some criteria input that you needed to cover a particular branch. Also, we noticed that the mutation is one of the main operators because, the idea behind the mutation is that it's introduced a new statement, a new input to the test cases from the selected randomly from the input domain. However, the standard mutation operation randomly changes the test case without enough guidance. It is just random select an input from the input domain. So as a result, we thought that given some domain knowledge, it can be very easy to improve the initial population and the mutation operator. And here's where we introduce a guided genetic algorithm approach that uses static analysis to set the initial population and guide the mutation operator. So guided genetic algorithm uses static analyze to generate test cases that focus on only methods that for a class under test, for the program under test, that help to cover a target branch. Some targets really need specific inputs to be covered. So how it works is that GGS starts by statically analyzing the class under test and identify all the target branches. This is the first step. And then each target branch, GGS identified the following 4 sets of inputs. The class initiator set contains all accessible methods that initiate the class under test. And state modifier set contains all accessible methods, only public methods here, that may directly or indirectly modify a data member to produce a desirable object state that help to cover the target branch. Another set is the target viewer set. So it contains all accessible methods. Whenever I say accessible, it means the public method that contain the target branch. So we need to have a method that can reach us to the target branch. And finally, the relevant set contains all the methods that do not affect either exist in the test cases, don't affect the probability of covering target branch. So as an example here, as you can see here, if we have these two target branches or these four target branches, we identify the class instantiator as the stack itself, that's the constructor, and then state modifier, which is the push and pop. Those two methods, or these two methods, can change the field size. You can see one increase and one decrease. And then we have a target viewer here, only push, because the isFull is called by the public method. So we only have, and the irrelevant, whether it exists in the test case, is not going to impact on this target branch. Based on this information, we created our we set our population by selecting randomly a target branch, which is number 8 as an example here, and then select a method from the class initiator and select some method from the state modifier. And at the end, we put the put in the test cases the target view finder, that method that can reach us or can call that the target branch. On the other hand, we also in the mutation operator, we randomly, when it's the GA starting processing mutation, it's randomly select a target branch that is not covered and look at those test sets and figure out which method can be removed, which method that can be added to the test cases that helps to cover that particular branch. So we evaluate our branch here with 6 approach with 6 popular Java projects as subjects in our evaluation. All these projects were used in the previous studies. Random testing is one of the most fundamental and most popular testing. That's because RT is easy to implement, scales to large programs, and can be used in its own as a component of many other automated testing. We select ICICT also because it represents the state of the art of the search-based testing. We run each class in this project, we dedicated 2 minutes either to cover all the branches or the timeout is going to be 2 minutes. So as you can see here, this figure represents the box plots of the branch coverage achieved in 120 seconds per class under test by each tool on the 6 projects. We use R here to present this data, and our result shows that random achieved the lowest coverage among all approaches of except for the nano XML projects. Also, as you can see here, our result also showed that ICICT achieved almost the same branch coverage on common Apache common.cli and common Kodi C projects. As also, it's very clear that GGA beat all the 2 approaches, the random and the ICICT. And we believe that achieving such high branch coverage compared to random testing and ICICT is significant, since the branches that are not covered by these approaches are generally quite hard to cover. Yeah, so that's what we talked about, the testing, the different approach people use, and then give you a little bit a picture or idea about what the genetic algorithms, and then also the approach that we implement to improve the testing of program. Thank you.
Thank you very much for that. Dr. Chu, do you have any questions?
Yes, great. Thank you, Ali. A very promising algorithm. I wonder, I feel that this algorithm probably is more suitable for kind of a screening process, i.e. when you're trying to debug the all the detailed parts of the code. And also, is it a kind of semi-automatic process, or you will see a hope of a fully automated screening process?
This is actually one of the advantages of GGA. It is fully automatic. It is just, but it has two different steps. Let's see here if it's mentioned here. So yeah, the first one, oops, sorry. The first steps, it's to instrument the program under test. What does that mean? To add some criteria, we use suit tool to instrument the program under test, to add, as an example, the fitness functions. So we can, when we execute the program under test, we know which branch that we covered and how far we to cover that particular missing branch based on that one. And it is fully automated. It doesn't require any input, except of course setting the time and running those tools. Yeah.
Yeah, great. Thank you, Ali.
No worries. Thank you.
Thank you very much, Ali.
Moving
on to our next speaker is P. Bujibabu from India, whose paper title is Design and Implementation of an Efficient IIR Filter Architecture Using Merge Delay Transformation. So if you'd like to unmute yourself, and then we can carry on with your presentation, sir.
Yeah, good evening, sir. I think I'm visible and I'm audible.
Yes, we can see your PowerPoint and we can hear you clearly.
Yeah, thank you. Good evening, all. Good evening, Chair. So, welcome to my session. That is, my paper ID is Design and Implementation of Efficient IER Filter Architecture Using Merge Delay Transformation. So I'm a PhD scholar. I'm working from University College of Engineering, JNTU, Kakinada. And I'm working under the guidance of Dr. K. Babulu from Kakinada Jawaharlal Nehru Technical University and Mr. Kamaraju. So Dr. M. Kamaraju, Professor and Mentor, Department of ECE, Gudlawalleri Engineering College, Andhra Pradesh. So actually, as per the guidelines of my research, I supposed to make a potential comments on the selection of particular IER filter. So that's my objective. For that, when I started my journey to design the filters which are required. And just by taking a problem statement, thereafter I designed with the initial data of availability. And I just working through that, I identified one by one technique, wherein I struck with merge delay transformation. That's why now I'm in a stage to explain my comments with the merge delay transformation. So these are my contents for today's presentation: introduction, problem statements, scope of IIR architectures, and then a realization of its architectures, comparison of architectures, IIR filter with the help of Simulink model. And initially, to make a note on the designing track, initially I used a FDA tool, that is Filter Design Analysis tool, which is available from MATLAB. Later on, to verify the characteristics of filter, that is phase and frequency response, as well as the attenuation characteristics of filter, I use the MATLAB platform only. And then it's not enough for me to characterize the filter. I supposed to verify the characteristics in terms of VLSI domain. So I just use system generator. Okay, using the system generator, I supposed to design the filter with the help of Xilinx modules. Thereafter, I could able to successfully convert HDL codes for the filters which I designed with the help of MATLAB functionality. So once after satisfying the functionality only, then with the help of same set of platform, I could able to design by using system generator, and the same system generator blocks I could able to get its HDL code. Thereafter, the HDL codes are simulated by using Xilinx Vivado tool. And in the Xilinx Vivado tool, yes, I know few parameters are there to define the performance of any circuit in terms of VLSI, that is power, area, and delay. So even load also, load of that digital IC. So I just applied different conditions of the design circuit, and then I observed some changes as per the set of inputs. And conclusion and future scope along with the references. Yes, I know the introduction portion is lengthy, but I wanted to make a note on that. Yeah, today man is not ready to walk, even he's running, and he's not waiting for his colleague to walk. He is also making his colleague to run with more than enough amount of velocity. So in such a way, the same person is also making circuits to run over and over speed. It doesn't bother about how much speed they are running and at what ambience, what about the temperature withstand, what about the input conditions. So the person has to make a comment, potential comments on the ambience in which all the circuits are running for giving the response what the man expecting as per the today's requirement. So in that case, I selected the signal processing element like IER filter, and the platform is VLSI design. So this is my problem statement: performance evaluation of digital IR filter architectures for low power DSP applications. This is actually my PhD problem. And for that, my initial steps are, first thing is digital filter key design issues, performance parameters of digital filters, realization of various possible architectures. Possibility means in a normal platform as well as in a modern platform where modality is coming with the expected performance or possible with the new designs. And the next one is proposing or identifying the effective filter. It's not enough for me to design the filter. I supposed to pick up the one which is best in terms of expected performance parameter in terms of VLSI constants, as well as parameters in terms of its functionality. Both the things I supposed to concentrate during the design. That's why, so in fourth step, I have to identify or propose the effective structure. Okay, and I supposed to use some kind of algorithm so to make it effective. And so the outcome of the fourth step is reducing the final required hardware, reducing the number of internal modules. In turn, I could able to reduce the overall area required for designing a system or a subsystem or a lower level module. And finally, whatever the filter I selected with an acceptance, I supposed to use that filter in any prototype, such like DSP, and I have to prove that the modified filter is more efficient than existing filter. So that is my final outcome. So during my PhD journey. So possible realizations and can be transformed. So yes, there is different set of variants that are possible during the design. Okay, can be modified by incorporating MDT. Right now, I just worked out the MDT, but later on, I also identified that more advanced techniques are also there. But if I use only advanced techniques, I cannot make a comment on so more advanced. Okay, so when I buy an IC, I supposed to know the least cost as well as the best cost. Even I have to trace what about its average cost. So initial filter is not good, and the filter with the MDT is good. So unless until I know the next level, then I'm sticking with MDT only, as I'm making MDT is only the best. But later on, I could able to identify further also. But now I could able to present the things with MDT And in my next paper, I wanted to go with the next level of algorithm with more efficiency. So these are the possibilities I worked out. Whatever the specifications I selected, all the possibilities, because I don't want to leave any single possibility in selecting the final possible best and effective architecture. So four possibilities: direct form to cascade and parallel form. Even each and every one is applied with bilinear, impulse invariant, approximation of derivatives, matched edge transformation. Even after that, so yes, from the first category I can choose one, and that selected one can be transformed with these four options, and the selected one can be passed through these four options, and whichever is the best can be processed with the help of merge delay transformation right now. So yes, I can make a comment on normal, which is even best among the set with respect to the one which is defined with the merge delay transformation. So method like balanced truncation, Hankel optimization will also be used. So somewhat superior than MDT. Yeah. So final architecture and then proposed DSP. This is my actual journey. So for that to prove, I selected one problem statement with these specifications, and I got this architecture with initial design process. So wherein I just identified different elements required, adders required, multipliers required, delay elements also required. Delay elements means flip-flops also required. If I consider the total number of modules required to design this one, number of adders are 6, multipliers are 7, and number of delays elements are 6 itself. So as a whole, a total 19 elements are required. 19 sub-modules are required to define this block or this IIR filter with these specifications. And later on, I will explain how much the number can be reduced. So these are the internal modules. Even I also concentrated on what is the possibility of internal module structures. So I worked out, I observed Cosystone adder is somewhat giving the less amount of delay among all the things. But again, I have to incorporate the same Cosystone in final structure so as to identify the overall effect or impact on the IIR filter. So as per the specifications, yes, these are the modules. See here, 7, 6, 6, total 19 sub-modules are required. This is the case with the direct form one, which is implemented in bilinear transformation, which is of Butterworth type. Okay, and if I left the other structures, I would have forgot about the best advantage. See here, multipliers are 3, adders are 3, delay elements are 3. Means 9 elements or 9 submodules are enough to define the same functions. So here 19 submodules required, but 9 submodules enough. So with the variation only, without going for the optimization, here I could able to define the filter with 9 submodules instead of 19 submodules. Means more than 50% of area could be saved in terms of a defined IC. So these are all the defined and realized architectures as per the specifications. As I said, I don't want to leave any single option in making a comment, which is required for me to prove the structure as efficient. Yeah, these are the performance parameters. So these performance parameters are verified with the help of Xilinx Vivado tool by converting that structure from Simulink. The HDL code is generated. So this is the system generator model by using Xilinx block set, which is available in system generator, which is configured with MATLAB as well as Xilinx Vivado. So these are the performance tables. So as I told you initially, I run my circuit with each and every cases. I set a constant frequency. I just varied all the loads as well as switching activities, because I know the power equation, general equation for power dissipation in a circuit is P equal to alpha T into VDD square, F clock and C load. There are influencing parameters. C load, that is load component, F clock, operating frequency, and VDD, applying voltage. So in prototype, it is possible for me to set different values, and I can observe the performance in terms of its power, area, as well as delay. See, this is the I think I can provide. The first one is without the merge delay transformation. So I can make a comment like, see here, more than 100 watts of power observed, and I just wanted to make a note here. These things are verified at the highest possible load and at the highest possible. See here, my load is 200 picofarad. Generally, 200 picofarad load is not applied in any kind of IC, but it is for the sake of understanding or for the sake of its performance verification, I provided 200 or more than 200. And with the FDT, yes, see here, less than 80 even, but frequency range is same itself. So I can say by comparing these two plots, so with MDT is good to select, architecture with MDT is good to select for the better power performances. So the equation and its corresponding model. Another equation, optimized equation by using a balanced truncation. Yes, I just for the sake of reference only I placed this balanced truncation structure because balanced truncation is more superior than merge delay transformation. But right now, I don't want to make a comment on the number of modules required. Yes. So to conclude, with this amount of time, I wanted to conclude that in designing or in selecting the architectures which are required for signal processing modules like IR filters, one can go with merge delay transformation or a balanced truncation methods to design effective filter architectures for the best power, area, and delay performances. So thank you. Thank you very much for your patient listening.
Thank you very much. Dr. Chu, do you have any questions?
Oh yes, I think it's very interesting. It is. I think there's quite a few very classic names has been mentioned. That reminded me the analog electronics we probably studied in the first year for many years. The Butterworth Chebyshev 1 and 2. I think it's probably around out of time. It's interesting piece of work. And great to see that. Thank you.
Thank you, sir.
Thank you very much. We'll move on now to our next presenter. It's Sony Asmolo Fode. I hope I'm pronouncing that right. It's from Indonesia, and their paper title is Prevent the Occurrence of False Signals in the Power Transformer Internal Protection in Substations to Improve Reliability with Differential Operations Amplifier Safety. So over to you, sir. If you could unmute yourself, and we can start with your presentation once you're ready. It seems you are here, sir. I'll ask you to unmute if you can see that message pop up.
Hello?
Yes, we can hear you now, sir. We're having some trouble hearing you.
ICICT 2021 in London. With our paper is present of
Dr. Chu, are you able to?
I can't hear it.
Sorry, sir. We're
Very-
unable to actually hear you clearly enough.
In progress.
If you want to try and maybe rejoin the session, that might try and solve it. What we can do is move on, and we'll come back to you once the next presenter is finished, sir.
In the former transformer and the minus pattern and
Sorry about that, sir, but we're going to have to move forward. Hopefully you can fix that technical issue. So, sorry about this. Our next presenter is Ivan Nedyalkov from Bulgaria, and his paper is Ensuring Communication and Information Security of Energy Storage Systems. So if you can unmute yourself, and we can start your presentation.
Okay, hello.
Yes, sir, we can hear you clearly.
Yes, loud and clear. Hello, Ivan.
Hello. My name is Ivan Nedyakov. I am from Southwest University of Etruski, Volgograd, Bulgaria. I'm going to present our work ensuring communication and information security of energy storage systems. The electric vehicles and all kinds of electric non-rail vehicles are rapidly entering our world. Therefore, there must be proper infrastructure for charging them, which are the charging stations. This charging station can be combined into a common network, like charging station network, like a retail chain of gas station. Additionally, this charging station must exchange information between. Therefore, there must be a communication subnetwork, which is used to exchange information between the charging station and the charging stations and the control center. The exchange information can be service information about the payment itself, and all kinds of information. The charging network can be divided into two subnetworks: the communication subnet, which is discussed in our paper, and the power part of the network. This figure shows the idea of the communication subnetwork. The internet is used for creating the connection between the charging station and creating the communication subnetwork between the charging stations and the control center. The network devices that are used for creating this network are router and switches. The modern power electronic device now have the capability to connect to a network, especially to IP networks. By connecting to these networks, they immediately can be subjects of cyber attacks. The major two groups of cyber attacks are attacks that are used to collect or alter the information, like the man-in-the-middle attack. The figure here presents the idea of the man-in-the-middle attack. Here, the man-in-the-middle attacker disguises himself as the charging station for the control center and disguises as the control center for the charging station. When the charging station and the control center starts to exchange the information flows through the attacker and not through the original connection. So the attacker can collect this information or alter this information and send it back to the charging station and the control center. And the second group are attacks that are used for restricting remote access to network devices and making them inaccessible. These types of attacks are not used for gathering data or altering it. In the IP network, there are several techniques that can be used for protecting the data, like VPNs, blockchains, intrusion prevention system, intrusion detection systems, and other. Now the internet is the cheapest and the easiest way to connect two devices at great distance. But when using the internet, the devices that are connected to the internet can immediately become a subject to cyber attack. So the connection you created between these two end devices is not so secure. It can be vulnerable and can be attacked. So what can we use to create a secure network that is that allows the data communication at long distance and can be disconnected from the internet? This is the optical network, and one service that they provide for years, the dark fiber. The dark fiber presents a leasing of a fiber or several fibers from optical cable to a user. The user can use these fibers to create a connection between two end devices. This is the idea of the dark fiber. And as you know, the specification of the optical fibers allows data communication of long distances. The charging station provides charging. This is their service. And after the charging is done, the user must pay for this service, the energy he used to charge this electrical vehicle. If the charging communication subnetwork is made with the help of the internet, these charging stations can be vulnerable to cyber attacks, and the data that is exchanged in this subnetwork can be attacked or can be modified. And this is not very good, because especially when the exchange information is the payment information. So how can we protect this information? Well, this is done with the help of the dark fibers. And this is the purpose of our paper. We present an idea of creating the communication subnetwork of the charging station by using dark fibers. This figure here shows our idea. This presents a country where the charging station owner have several charging stations placed in different parts of the country, and they are connected with the help of the dark fiber in one communication subnetwork, which is safe and secure. The charging station can access the dark fibers through the use of the media converters. The media converters are units that convert the signal from white to electricity and from electricity to white. What are the advantages of our idea? The biggest advantage is that with the use of the dark fiber, we can create a safe and secure communication network that is disconnected from the internet. This network is locked and it's almost inaccessible. The transmission speed is almost unlimited because the only user of this dark fiber network is the owner of the charging station network. The owner of the charging station network has full control of the dark fiber communication network. By using this dark fiber communication network, the owner of the charging network can create his own secure, safe, and security payment system. And thus, the exchange data in the dark fiber is not monitored by the telecommunication operator. Of course, there are some disadvantages of our idea. The first one is the charging station may be placed in a place where the chosen optical network provider cannot access it. So the owner of the charging station network must make additional investments of creating an additional optical path from the charging station to a place where the optical network operator has an access. The second disadvantage is initial investments. And the third disadvantage is when there are problems with the access to the dark fiber or problem with the dark fiber itself, these problems cannot be fixed immediately because, as I mentioned before, these dark fibers are not monitored by the optical network operator. These failures must be sent to the optical network operator by the owner of the dark fibers of the charging network, and when they know about these problems, only then they can fix them because they're not monitoring the fibers. And the main conclusion is we propose an interesting idea of creating a safe and secure communication network that can be used for communication subnetwork for charging stations. And that's all.
Thank you very much. Dr. Du, if you have any questions.
Thank you, Jay. Thank you, Ivan. Now, I think the idea is quite interesting. No, it's not a critics because it's sort of my area. Now, first of all, the throughput of the data you collected or need to communicate between the charging station and the data center, what you called it, are actually very, very sort of small or substantially a kind of a little amount of data. Give you an idea, so for the current Tesla station, the average data they collected per station is literally less than 10 megabytes per day for all the vehicles. Now, first of all, the idea of fiber is a little bit a kind of waste of money. And also, I wonder if you heard about the data over power cable. And so the power connection itself is capable of transferring all the data. And this is some people in Tesla already doing that. Is they actually put a kind of power modem attached to the charging station, actually use the same power line to actually transmit the data collected from the charging station. So have you ever sort of that and compare your black fiber with the data over the real 200 volt or 300 volt power supply cable?
No, we didn't compare this, but maybe this is interesting idea for a future work to compare between using the dark fiber and this. The dark fiber here in Bulgaria, there are not many electric cars. Many of them are just electrical bicycles and they're charging them at home, but it's an interesting idea to compare them and to see which one is the better.
Yeah, because you know, at the beginning, actually, we the network industry, the data industry, actually tried to use the existing grid, the national grid, to transmit the data. But the only thing stops them from carrying on is health and safety. But now, because of the new development for the Tesla charging station, that idea has been bring back to surface again. So there's probably some. It's only my comments anyway. That is an interesting piece of work. Thank you, Ivan.
Thank you.
Thank you, Ivan. We'll move on now to our next speaker, who is Rashidul Islam from Bangladesh. If you're here, sir, if you want to unmute yourself, and we can carry on with your presentation. Hello, sir. Can you hear me?
Sir, am I audible? Hello, sir.
Yes, I can hear you now.
Sir, can I share my screen?
Yes, there's a green button which should allow you to share your screen right now.
Okay, sir. Sir, is it visible?
Yes, we can see it and we can hear you as well. So if you want to continue.
Okay, sir. Hello, everyone. Welcome to our paper presentation titled Design of an On-Body Rectangular Microstrip Antenna for the diagram.
To interrupt you quickly, but there are some things blocking your presentation on my picture. I'm not sure if that's the same for everyone.
Actually, it's in his presentation.
Sir, am I audible?
I can hear you perfectly, but there are some gray bars on your presentation.
Sir, I think there was a problem in internet, sir.
Okay, if you want to continue, and we'll see if it rectifies yourself. If you just want to, sorry about that.
Okay, sir. So welcome to our presentation titled Design of an On-Body Rectangular Microstrip Patch Antenna for the Diagnosis of Breast Cancer using S-band. Our paper ID is 607. Myself, Rashidul Islam, and I will be the presenter of this paper. Our co-authors are Fardin Mahbub, Syed Abdul Kader Al Nahian, Shohardo Banerjee Akash, Raja Rashidul Hassan, and Mohammad Abdur Rahman. We are from the Department of Electrical and Electronic Engineering from the American International University, AIUB, located in Dhaka, Bangladesh. Now table of contents. This is the table of contents. First, I will be talking about the research goals, then introduction, then the reason of using microstrip patch antenna, the impact of the research in our society, block diagram, the design and simulation, output results, comparative study, future application, conclusion, and then the references. And now research goals. Our research aimed to design a microstrip patch antenna in the CST software to diagnose breast cancer, which is capable of microwave imaging, and to create a breast phantom in CST with cancer and tumor cells. Our research next target is to apply the antenna on the breast phantom for deducing the antenna's performance. Moreover, to obtain a balanced radiation pattern to maintain the health issues of people and to get a higher value of return loss, and as a result, the antenna can accept more radio frequency energy. Now, introduction. According to the World Health Organization, breast cancer is one of the biggest health challenges globally. This disease causes 15% death of women related to cancer every year. Previously, numerous methods such as ultrasound, radiography, magnetic resonance imaging, X-ray mammography, etc. were used to identify the tumors or cancer cells in the breast. These previously used methods have some drawbacks and limitations. Among the recently invented techniques for breast cancer diagnosis, microwave imaging is the most effective technique. Moreover, there are benefits of microwave imaging using a microstrip patch antenna, such as convenience, potentially low prices, and being a non-ionizing, danger-free option. Now, the reason of using microstrip patch antenna. Microstrip patch antennas operate at microwave frequencies where traditional antennas are not feasible to be designed. This particular types of antenna is smaller in size with lightweight, and as a result, it can be easily implantable on the human body. These antennas have lower fabrication costs because they are easily etched on any PCB and will also provide easy access for troubleshooting during design and development. They can support multiple frequency bands such as dual band, triple band. Now, impact of the research in our society. By using microstrip patch antenna with microwave imaging, breast cancer can be diagnosed in a better way compared to some previous methods. Since microstrip patch antennas are cheaper, society's poor people will be beneficial, and as well as it will be useful in developing or underdeveloped countries. Moreover, it is a non-ionizing and danger-free option, which is significant advantage considering people health issues. Now, block diagram of the design. This is the block diagram of our design. First, we have to select the application, and over here, our application is the breast cancer diagnosis. After that, we have selected microstrip patch antenna based on our application. Then we have done a thorough literature review regarding these all concepts. In this paper, we selected a frequency of 2.3 gigahertz and a substrate material known as FR4 lossy. Then we made different types of calculations based on the formulas and determined the dimensions of our antenna. After that, we implemented the antenna and created the Brest phantom in the simulation software CST and analyzed its performance after applying the antenna to the phantom. In the end, we compared our results with previous works that have been done before. Now, basic equations. These are the basic equations that we have used in our paper determining the dimensions of our patch antenna. Over here, you can see that we have chosen the width of the patch, also the effective dielectric constant, the effective length, the actual length of the patch, and the width of the feed line. Now, design and simulation. The free space antenna was designed by the following parameters given on the screen. You can see over here, all the parameters are given along with its dimensions that we have used. Here on the left, you can see the simulated antenna's geometry with proper leveling. And on the right, you can see the 3D model of the simulated antenna. Now on the left side, figure 3 represents different parts of the design Brest model, and on the right side, table 2 represent different parameter values of Brest tissues. After creating the cancer affected Brest model in CST, the designed free space antenna was applied to the phantom at an operating frequency of 2.3 gigahertz. Figure 4 and 5 shows the cancer affected Brest model and the location of the tumor respectively. Figure 6 represents the return loss of the antenna in free space, and figure 7 illustrates the return loss of the antenna with cancer affected Brest phantom with their obtained value of minus 37.276 decibel and minus 45.720 decibel respectively. Figure 8 represents the VSWR of the antenna in free space, and figure 9 represents the VSWR of the antenna with cancer affected Brest phantom. A VSWR of 1.0104 was obtained by applying the antenna in the tumor affected Brest model, and a VSWR of 1.0277465 was obtained in free space. Figure 10 shows the far field radiation in the cancer affected Brest phantom, and figure 11 shows the surface current in the cancer affected Brest phantom. Figure 12 represents the radiation efficiency pattern in the free space, and figure 13 represents the radiation efficiency pattern for the cancer affected Brest phantom. A radiation efficiency of minus 4 dB and minus 5.54 dB were successfully achieved in both free space and in the cancer affected Brest phantom respectively. Now figure 14 represents the specific absorption rate calculations of 1 gram tissue. It can be seen that the maximum value of specific absorption rate for 1 gram of tissue is 0.483 watt per kg. Figure 15 shows the 3D radiation pattern directivity in the cancer affected Brest model. And figure 16 represents the 2D radiation pattern directivity in the cancer affected Brest model. Now comparative study. Various antenna parameters such as return loss, directivity, and tumor size of the Brest phantom of many previous research papers were analyzed and compared. Over here, you can see that our S11 value has the highest value of minus 45.72 dB compared to the past research work. Now future application. Substrate material and substrate thickness of the antenna can be changed in the future for better performances. return loss can be made higher by changing the design parameters and so that the antenna will be useful for breast cancer diagnosis. Moreover, directivity can be increased by changing the patch radius and ground plane radius. Finally, different feeding techniques can be used. With different shapes of the patch for better output performances. Now, conclusion. A rectangular microstrip patch antenna was designed successfully to diagnose breast cancer at an early stage with an operating frequency of 2.3 GHz. A human breast phantom was designed and a low size tumor of 5 mm was placed on that phantom. A good value of return loss and directivity were achieved after applying the antenna on the tumor affected breast phantom. Overall, a better output parameter has been optimized compared to some previous research work. Now references. These are the references that we have used in our research. Thank you, everyone. Sir, can I stop sharing the screen?
Yes, go ahead. Thank you very much for your presentation. Sir, if you have any questions.
Thank you, Jay. I think it is very narrowed study. So, Rashido, now why don't you consider the shape of antenna before you actually consider the design of the antenna itself? Because if you look at the emission patterns, obviously a dish-shaped antenna does a much better job than a dipole antenna or Yagi antenna. Now, your antenna is simply kind of shaped. I know the size of antenna doesn't matter. So what is the particular reason you actually leave the shape of antenna to the later stage, but just consider the size, the organization of antenna first?
Sir, can you repeat, please, sir?
Oh yes.
So
why don't you consider the shape first, and also what is the impact of using different materials of the antenna, and also what will be the kind of, for instance, this problem can be easily solved by 4 smaller antenna rectangles rather than one big antenna. So have you considered a kind of multiple antenna scenario versus a single antenna scenario, a single antenna with a fixed shape and a antenna with different shape? So what is the rationale between all these different relationships and the comparisons?
So we have compared, sir, the shape of the antenna also, so with different research paper, previous research paper, sir, and the size of the tumor also. So in some previous research paper, sir, there was the size of 10 mm or 15 or 20 mm, but sir, our size is 5 mm, sir, which is lower compared to the others, sir. So with a lower size of tumor, sir, our antenna, sir, gives better output, sir, as a result. So we have also tried with, sir, different substrate material also, but sir, by using FR4 substrate material, sir, our antenna, sir, gives better output. So we have used FR4 substrate material without using the other materials.
Okay, that's fine. And also my other suggestion is could be a kind of a collection or kind of multiple antennas from different angles. That's probably will be a bit more helpful. It's my observation anyway.
Yes,
thank
sir.
you.
Thank you, sir. Yes, sir. Thank you, sir. So is there any question to the audience?
If there is, no. Okay, what we'll do now is we'll quickly go back to see if Mrs. Sawhney Small Foldy is he is still here, I believe, on the call, if I'm not wrong. No, it doesn't seem like it. Not to worry. What we'll do is we'll conclude the session now. So I sincerely thank you thank our authors for their excellent presentation and contribution in this session. And I hope that our participants for being I thank the participants for being part of this international Congress, and I hope that this was informative and knowledgeable as well. All presenters will be getting their digital certificates through the mail within 2 working days. And further to this, all papers have already been submitted to Springer, and the publications will be live to view in the next 4 to 6 months. So that is done kindly with the operation and management of the team of ICICT 2021. And I would like to thank our chair, Dr. Xu, for chairing this session. And I will quickly display. Apologize for this, sir, but this is just a quick display of our gratitude, just a certificate. I hope you can see this. Are you able to see this, sir?
That's fine. I can see my name.
I'm not
Thank
sure.
you, Jerry. Looks great. Thank you. Well designed.
Yeah, I'm sure if it's come up now. Sorry. So
yes.
Again,
yes.
I would like to thank you, sir, for your valuable presence. And just one last thing before we do conclude this session, if it would be at all possible for all of you to start your video for us to take a nice little snapshot real quick for some memories. If you could all do it, that would be perfect. I'll just give you a few seconds to do that.
Yes, that's very nice. Thank you, Jay.
Thank you. 1 second, it's just, there we go, smile. Perfect, I think that is done. Great having, talking to you all, meeting you all. I hope you all stay safe. And thank you very much for today. And I hope you good health in the coming future. Thank you.